gonna do my best. Yeah, so me and Arne, we are civil engineering students doing the Perkpolder tidal basin. Perkpolder is situated in Hulst in Zeeuws-Vlaanderen. Yeah, you can see the area over here. So what's happened, the polder has been reopened to the Western Scheldt, right here. It was closed, so they opened it again to let the water back in. Now we're going to see what changes are happening to the area. Yeah, so the polder is transforming into a tidal flat. It's also, they want to create a natural preserve area over here. So, of course, it's been 2 years since it's been open, so there's a lot of data already collected. We're also going to use that data. Yeah, our research questions, so what are we specifically going to do or look at in our research? Yeah, the main question, what morphological changes will take place in Perkpolder tidal basin from open, so when they reopened it to the Western Scheldt until the end of 2017, so when our minor ends. And what contribution do these changes have in relation to the safety of the surrounding areas and population? So yeah, we're going to focus on the safety since we're civil engineering students, and yeah, how the dike and the tidal flat and everything provides safety from the water. Yeah, our sub-questions, how long does it take for the tidal area to be high enough and for the vegetation to be developed enough to offer significant protection and wave reduction for a dike? So, of course, normally the dike was the only thing protecting the land behind it from the water. Now the tidal flat is also providing protection. But since it's a tidal flat, also vegetation can grow on it. It also has an effect on the safety. How does a tidal flat give more protection to the area behind the dike? Yeah, so we're going to see specifically how it will affect the safety. So does it reduce the waves, the amount of water that comes near the dike, things like that. Yeah, can vegetation provide more protection besides the dike, and how does it contribute to safety? Yeah, so the vegetation itself, how does it affect the water? When is there going to be enough vegetation to give noticeably more safety? Yeah, so since now there's not a lot of vegetation, at what point will it be significant to say, okay, now there's more protection thanks to the vegetation itself? And then what kind of maintenance is needed in the total safety system, the dike, the vegetation and the tidal flat? So yeah, of course, the dike, it takes maintenance to make sure it stays safe and usable. Now, since the tidal flat and the vegetation and everything is also a factor, of course, less maintenance is needed, and we're going to give an estimation on how it will be affected by those things. Data collecting and processing. So yeah, of course, there's a lot of data, as I previously said, so we're going to build upon that data. Heights have been collected for cross sections, the velocity, discharge, sedimentation. We're going to continue collecting that data. Also, we're going to keep using the DGPS for the heights and the cross sections, and possibly collecting sediment in different areas in the area. Additionally, since we're civil engineering students, and to focus on the defensive aspect, we're going to see the height of the dike, wave runover. So, see if there are waves in normal conditions and storm conditions. The influence of the wind on the safety, so how the wind affects the waves in the area. And of course, a safety factor for the vegetation. We're going to monitor the water level and the rise of the water in the area, and the data will be collected by us for a few days every month. I think 4 days we should be able to collect everything. So processing and comparing the collected data, of course, so the data we collect, we're not just going to leave it there. We're going to process it to calculation, graphs, drawings possibly. That might give us an insight on what might happen in the future. So we can make an estimation on what we think will happen. Now, it's only been 2 years of research, so we can't give an accurate estimation for like 10 years in the future. Yeah, but we'll give a rough estimation for what we think will happen. Comparing with the older data to see what's changed. So of course the height of the area will be changed, and maybe see how the channels have changed. And then comparing to other areas that have been to a similar process or are going to take a similar process. The end results of our data we are going to provide in the form of a report. In this report there will be various graphs and lists, possibly drawings, to explain everything and all the data we collected. Yeah, extra maps in ArcGIS, the height and depth will definitely be in there. Yeah, data according to the water flow and the channels and everything in the area will be provided in ArcGIS maps. Thank you for your attention. Are there any questions?
Students first.